In this video, we're going to prove the following fact. If H is the subgroup of G, and we define N of H to be all members of G such that A times H times A inverse is equal to H, then this set, N of H, is a subgroup of G. And in fact, every element in H is a subset of N of H. That one's kind of obvious if you think about it, but I'll show it to you. If you like watching mathematical proofs like the one I'm about to give, you should seriously consider subscribing to my channel, as this is what we do here. We prove mathematical facts. Okay, so to show that N of H is in fact a subgroup of G, we need to show closure and inverses. So let X and Y be in N of H. Well, what does that mean? Well, X is in N of H implies that X inverse is equal to H, and Y is a member or an element of that set, implies that Y inverse is equal to the subgroup H. So now I want to show that XY is in there. So let us compute XY times H times XY inverse, and we want to see if we get H or not. First thing I'm going to deal with is that inverse. This is XY times H times Y inverse X inverse. I'm going to group those elements together. So I have X times Y, H, Y inverse times X inverse. But this is H. This is H. That's how we got to be in N of H. If this equals H. So this is X times H, X inverse. But that's H, because X is in this special set. X times H times X inverse equals H. Okay, so this implies that XY is in N of H. But that implies we have closure property. Now I have to show inverses are in there. Okay, so let X be in N of H. By definition, that implies X times H times X inverse is equal to H. Now, on both sides, I'm going to multiply, well, on the left side, I'm going to multiply by X inverse, and the right side by X. And I have to do that to the other side. On the left, I'll multiply by X inverse, and on the right by X. Okay, now we'll group it. This, and that. So I have X inverse times X times H times X inverse times X. And this is equal to X inverse H times X. But that's E and that's E. So I have E times H times E. You know, that's H times E. That's H. One last thing. X is the same as X inverse inverse. So I have an element in G, and when I multiply it by capital H times the inverse of this element, I get back H. By definition of N of H, that implies X inverse is in N of H. And we started with N being in N of H, and we concluded that X inverse is in N of H. This implies N of H contains inverses. So N of H has inverses, N of H has closure, therefore N of H is a subgroup of G. That's part A. Okay, we just showed part A. Now I want to show that every element in H is in here. Okay, now, so part B. Now, let little h be in H. H times H times H inverse. This is little h times H inverse. But if you multiply an element that's in H by the subgroup H, you get back to subgroup times H inverse. Well, that's H times H inverse. Even if this is in H, little h was in H, that implies H inverse is in H. This is in H, and even if you multiply the set H on the right by an element in H, you get back H. Ooh, this is equal to H. That implies that H is in N of H. But H was just any old element in H. Therefore, H is a subset of N of H. And that completes the proof for parts A and B. If you're into watching math videos like this, subscribe to my channel. Please leave a comment. Definitely click the like button if you enjoyed this video. See you folks in the next video. Thank you for watching to the very end. Watch and learn.